Okay, here's part two of log functions. Here we have y equals 2 to the x function here. Notice what's going on here. Notice here it crosses at 1. Why? Because at 0, 2 to the 0 power is just 1, right? Well, what if we're going to look at some patterns here. Let's look at 3 times 2 to the x power. What do you think is going to happen? Well, let's see. Let's change this. It looks the same. Only difference, this changed to 3. See the pattern? If this value on the outside, if it's 2 to the x, if it was 5 to the x, it's going to be the same. But on the outside of this particular, we'll call this our base. And this number on the outside, we can call that our, whatever you want to call it. Whatever that value is, it's going to be your y-intercept. Understand that. And what if you forget? Go back and do the same pattern. Okay? If we use our graph theory, and if we add an x value, subtract x value, for example, let me write another function. We're going to look at our graph theory. Let's look at 2 to the x, put this in parentheses, x plus 4 plus 2. What's going to happen? If you remember with graph theory, you need to review this if you don't remember. But here we have a function plus 4. So x plus 4 is going to shift this entire graph 4 units to the left. This 2 is going to shift it 2 units up. And if you had to determine the domain and range from this, you just need to look at the graph and determine this. Let's graph it. Let's use a bold color, blue. Let's make it dark. Okay. Alright. Let's notice what happened. It shifts the graph. I'm going to go from my base, which is the red. That's y to 2x. It shifts this graph 2 units up, and it went over 1, 2, 3, 4 units here. Notice this is now your y-intercept. And to determine how far to the left it goes, the domain and range, the domain stays the same. The range is how low does it go. Well, notice here, this particular graph, let's go back to the original. Notice the y-intercept was here, and now the range was greater than 0. Well, if I just shift this up 1, 2 units, what's your range now? It's going to be greater than 2. And you just got to be able to look at the patterns to be able to figure this out. That's the best way to do this. Let's look at another function. Let's get rid of these. Let's look at some log functions and look at a few patterns. And then we'll be able to do some calculations. Let's look at, let's graph log of x. And our function looks like this. With this function, your value can never be negative, because if you plug in a negative function, and I can show you why in a minute, but you can never have a negative x value for a log. Never. It just won't work. It just doesn't make sense, and I can show you that in a minute. But here, this is what the function will look like. The graph theory works for this. If I were to take that same function and go x plus 5, well, x plus 5 inside of the parentheses would shift this graph 5 units this direction, and everything else will look exactly the same. If I were to shift this, take the same function and just go this function, say plus 4 out here, it would shift this 4 units up. And then from there, you determine your domain and range. See, the best way to do this, look at the patterns, look at the graphs, sketch your function, use advanced graph, it's pretty easy to do that, determine your domain and range from there. And I think this will do it. This is the end of part 2, and next we'll go to some actual calculations with logs and exponents.